Alaikum salam.
Walaikum assalam. We are doing dynamics today. This is our topic for today, and dynamics is one of the most loaded chapter coming very regularly in every paper 1, 2, 3, 2, 3, 2, 2, 2, 1, 2, 3. So it is a very appearing topic. I'm starting with the Newton's first law of motion, and Newton's first law says that Newton's first law says that the state of a system resists any change in its motion or rest state. This is actually law of inertia. Newton said that if something is moving, it will remain moving, and if something is at rest, it will remain at rest. I always prefer that when you come across a theory question, you always should try to look at the examiner reports rather than immediately going for the marking scheme. Generally, people have a quick response to marking scheme, and that's always an easy way to get out. So you people should have your own past paper books. And if you have your past paper book, you please open June 14, 22-3. June 14, 22-3. And I got my first part, which is a simple part. But just to make a habit that how we should improve our quality of language, look at this, how examiner reports are better to improve your level. Many candidates were imprecise in this definition. The majority emitted constant speed in a straight line or the resultant external force. So examiner want people to be very precise, but he says that many people were not precise in making the statement. So
Okay.
look at this definition, straight line.
Okay, sir. Understood.
So the examiner want to mention the straight line. A box slides down a slope. This is an inclined plane. The angle of the slope to the horizontal is 20. The box has a mass of 65 kg. The total resistive force R acting on the box is constant as it slides down the slope. Name and direction of the other two forces acting on the box. The weight of the box.
Yeah. And friction?
The weight of the box is like this. And he says that the box has a mass. The total resistive force acting on the box so these are the two forces are acting with constant and angle is 20. Names and direction of the other two forces acting on the blocks. We have done this topic in a good detail, and hopefully remember that there is a reaction force there is a reaction force,
Yeah.
which is, let me
Equal
call
to it.
it Y. Actually, he has already used the letter R. So I'm taking,
Say the name of the force.
yes, normal reaction. (65 G) is the weight. So what would be the other force? Obviously, the weight of the object. The weight of the object the variation with time of the velocity of the box as it moves down the slope is shown. V and T, velocity time graph. Use data from figure 3.2 to show that acceleration of the box is 2.6. When you have a velocity time graph, the gradient shows the speed. So we should try to work out the gradient.
So doesn't velocity time graph show acceleration?
I'm sorry, velocity time graph shows acceleration, and we need to find acceleration. I mentioned it wrong, sorry. Velocity time graph, gradient of velocity time graph shows acceleration. If we read the points 2, 6, if I take the extreme points 2, 6, and here it is 0, 0.8.
Bro, should we leave the meeting?
He'll probably come back.
Okay. Can you message him?
Or
So, sir,
Sorry, I lost the connection. And what was the answer for this calculation?
2.6.
2.6.
Yeah, 5.2 divided by 2.
Then calculate the resultant force on the box. Resultant force is always equal to,
Mass into acceleration.
yes, m into a. The mass is 65. The acceleration is 2.6. What is the answer of this calculation?
1.6, sir. So is it 65 kg? Yeah.
65 is kg. I think so. Let me double check. It
Yeah.
is 65 kg.
Yeah, it's 169 Newton.
169 means three significant figure. So if I read the question, I find the data they are giving is correct to two significant figure.
Yeah, it's 170.
Determine the resistive force R on the box. We know the resultant force, we know the angle. So we can now go for our resolution job, which we practice in our normal class. I have resolved it. The object is going downward. So how we can make the equation if an object is going downward, the resultant force is always equal to greater force minus smaller force.
Yeah.
If the object is slipping down, then mg sine theta would be the greater force.
Yes, sir.
Minus the resistive force. Mass is 65. Acceleration is 2.6. Even though we can put 169 also directly here because we have the final form there. So now this is the working.
Okay. So it's 49.
Sorry,
R is equal to 49 newtons.
whole exact 49 is coming.
It's 48.8 for I convert to 49.
November 14, 21/4. A trolley moves down a slope as shown. The slope makes an angle of 25 degree with the horizontal. A constant resistive force Fr acts up the slope on the trolley. So he has given us two velocities.
Yes, sir.
So if I mark it here, I'm preparing the force diagram because that will help me throughout the question. Even I'm not sure about the mass, but I know that so I have made the force diagram, arrows for the force diagram. The angle 25 will be shifted here. I don't have the mass, so I call it mg. He says there is a constant resistive force Fr, so I put Fr here. Let me call it X. The reaction force, normal reaction force. So that the acceleration of the trolley down the slope is approximately 3. So we have two velocities. One is, we have the time also. The first part we can do by a basic mathematics using the formula of acceleration.
So acceleration is 2.875 joule around to 3.
So 11.5 upon 4, 2.8.
Yes, sir.
Calculate the distance. Calculate the distance x moved by the trolley down the slope from 0 till 4.
Yeah.
So we have the acceleration, the particle was heavy, we have the velocities. So we can think about using equation of motion to A as something like that. Like,
We can also use S is equal to VT as well, yeah.
2as is equal to v square minus u square. U is equal to 0.5. V is equal to 12. Acceleration is 2.8. And distance is question mark. So if we simplify it, how much is 144 minus 0.25?
Sorry, sir. 144 minus
144 minus,
0.25.
yes,
143.7. So the answer is 25.7.
Is this the final answer?
Yeah. It's 25.66. Or the final answer is going to be 25.7.
Sorry,
It's
final
25.
answer is 25.
Yeah, 25.7, which is going to be 26, sorry.
Hmm. Figure 4.2, sketch the variation with time of distance x moved by the trolley. Now we need to find x against time. It means we need to worry about the gradient. We need to see the question, and we have the acceleration, we have the force diagram, the object is coming down. The velocity will be definitely increasing because it's coming down. As the object is coming down, it is a case of acceleration. We found the acceleration also. Velocity is increasing. So the graph should be a straight line. Graph should be a straight line. And should it pass through origin or not? That's a question.
So what are we doing now?
I'm waiting for the feedback because only presently the people who are there, they have to see the question, and I know velocity is increasing. I know
Yeah.
that velocity is increasing, but there are options. Velocity is increasing at a constant rate. Velocity is increasing at a decreasing rate. Velocity is increasing at an increasing rate.
Okay. So I think it's gonna be at an increasing rate. So
So we must have to look at the question. T is equal to 0, velocity is 0.5, T is equal to 4, velocity is 12. It's going downward, so velocity is increasing. I have the value at 0, the velocity is 0.5.
okay. So
X is the distance traveled by the trolley. So actually what I am thinking that should I get the graph from the start? Should I start from 0? Because obviously when time is 0, the velocity is not 0.
yeah. So it's gonna be sir, it should start from origin, no?
This is a question that I have actually questions. I have mainly two questions. Should I draw like this, like this, like this? I have 1, 2, 3. My first question is this. Secondly, should I touch origin or not? These are the two questions which will always come to a person who is drawing a sketch. This is November 14, 21, 4. Let me see the November 14, 21, 4. Look at this question.
This
So we
question
need we need to draw a sketch, and with the object is coming down, its velocity would be increasing down the slope. So it would be an increasing graph. But should it be increasing gradient or decreasing gradient? The point is that examiner says that the opposing force, let me underline, the resistive force is constant. The resistive force is constant. Now, if I select number 2, it will mean that resultant force is constant. If I select 2, it means V is constant, acceleration is 0. Option 1, option 2, sorry. Now, it is obvious that the gradient is the main game. Now, I know acceleration is not 0. I have found the acceleration, so I will reject option 2. Option 1, decreasing gradient. It means velocity is decreasing. It's a negative acceleration. 3 means velocity is increasing, positive acceleration. I have made notes on the screen and you people have the acceleration here. And as I mentioned already, when something is coming down, its velocity should be increasing. When something is coming down a slope, velocity should be increasing. So now give me an idea, give me a suggestion. 2 is already cancelled out. 1 and 3, which one of them should be the better answer? The object is coming down. 3 option. Okay. Good. So we have selected the graphs correctly, and this is a mind exercise. Sketches are always challenging. Remember that a distance, this is a distance time graph. As it is a distance time graph, I write here for reference. It is a I have shown all of my thinking work here. So you people remember it. How we did this question. I have done all of my thinking work. And now I will draw like this. It's not that much good. But examine. No, this is better. Copy down this working.
Yes. Done, sir.
The mass of the trolley is 2 kg. Show that the component of the weight of the trolley down the slope is 8.3. Now I go back to the diagram. That is why I want people to have their books so that they can scroll with me also. And sometimes they can look themselves also. This is the famous resolution. I made a cut here and I write mg sine theta. I have resolved the weight. He says the component of the weight of the trolley down the slope. So he's talking about mg sine theta.
So can you scroll up just to show it's theta?
Mhm.
So it's
So now look at this working.
yep.
Always get the answer in 1 sig fig more than the question. Question is in 2 sig fig. Always try to take out the 3 sig fig and round it to 2 sig fig for better presentation and better accuracy. So what is the horizontal component?
So it's 8.28. But this, you have to convert it to two significant figures, so it's 8.3.
8.28 what meter per second? Sorry, 8.28 Newton, right? And if we round it, it will be 8.3 Newton.
Yes, sir.
Calculate the resistive force Fr.
Sir, it's a greater force minus smaller force. And
The object is going downward.
yeah,
The object is going downward. So I will use the approach.
we subtract 8.3 minus the resultant force.
Resultant force is equal to greater force minus smaller force. Mass is 2 and acceleration was 3. So please get the answer for me. It's equal to 2.2, 2.28. So we did this question and we are stopping here and we will inshallah continue in our next class. Allah Hafiz.
Allah Hafiz, sir.